example, we are asked to maximize the following function. Z equals 5x plus 2y, and that is going to be subject to the following system of inequalities. X plus 5y is less than or equal to 35. 6x plus 2y is less than or equal to 42. X is greater than or equal to 0, and y is greater than or equal to 0. So this is, again, what we would call linear programming, where we are given a function that you could be asked to maximize this function or to minimize this function. Another term for the function that you're asked to max or minimize is called the objective function. So you might see that terminology as well. In other words, so after we solve the system, whatever solutions we get from the system, you will plug in those x and y values to determine what the solution is of the function in question that you're given at the beginning of the problem. So what we're going to do first, as we saw in the last video, in order to solve this system, we need to work with two inequalities at a time and find those intersection points, because we have to find the feasible region in order to know how to maximize this function. So the first thing I'm going to do is I'm going to graph each linear inequalities to obtain that feasible region. And to graph, you have learned many methods to graph. Some people find the X and Y-intercepts to graph. You could also take your inequalities, put back in the equal sign. You can put them in the slope-intercept form. So it really is your choice, or you could make a t-table where you choose values of x and solve for y, or vice versa. So you have options as far as graphing. Or again, you could use substitution to find those points of intersection. So what I am going to do in this video, I think I'm going to graph using the X and Y-intercept method. And if you have any questions about that, you can just send me an email. So let's start with equation number 1. I'll just number these. And if I want to solve, or if I want to graph this equation, if I want to find the x-intercept for number 1, that means I will let y equals 0 in that equation. So again, it's okay to replace the inequality with the equation just to get through the algebra part of the math and find what you're looking for. So if I want to find the x-intercept, leave x unknown, and where the y value is, we'll plug in as 0. So 5 times 0, that is gone, so x is 35. So that means the x-intercept for the first equation is 35, 0. So x is 35 when y is 0. The y-intercept, we do the opposite of that. If I want the y-intercept, I'm going to let x equal 0. So if x is 0, then we would have 0 plus 5y equals 35. We know the 0 is gone, so I really just have 5y equals 35. And to solve for y, I would need to divide both sides by 5, so y equals 7. So my y-intercept, sorry, I'm pointing at the x-intercept while calling the y, so if my y-intercept would be 0, 7. Now I can graph this inequality by plotting these 2 points. And notice that this is less than or equal to, so that means that the line that I draw will be solid. And eventually, when I get to the shading portion of this question, the direction less than or equal to means that we will shade below. So it's kind of nice to go ahead and start picking out all of the pieces of your information. So over here on the side, I'm going to start our graph for this example. And I'm going to do some guesstimating on my ordered pairs. So 35, 0, I'm just going to arbitrarily call this 35. So there's my x-intercept. And 0, 7, I'm going to say this is 7. So this would be that point. And my line should be solid. So I will draw a solid line. And that represents equation number 1. The next equation is 6x plus 2y is less than or equal to 42. So we'll go through the same process of finding the x and y-intercept. So the x-intercept, we can probably do this in some mental math now, right? So if I want the x-intercept, I can replace this y with 0, so that's gone. So I have 6x is 42. Divide both sides by 6. So x is 7. So our x-intercept is 7, 0. And then for the y-intercept, we let x equal 0. So if we replace the x with the 0, the 6x term goes away because it is now 0. So we would have 2y equals 42. And when we divide both sides by 2, y is 21. So the y-intercept would be 0, 21. Again, go back and look at your inequality. The line will be solid. And according to this, the direction we again are shading below. So I'm going to plot this one in pink. So what do we have? 7, 0. So we'll say this is 7, 0. And 0, 21, we'll say this is 21. And draw a solid line. So if you can see, we're starting to create this feasible region. And then my next two equations, we don't have to solve. They are already solved for us. So if we look at x is greater than or equal to 0, x equals 0 is here. So that means we are looking at x equals 0 starting at x equals 0, which is here, and going all the way up that y-axis. And then y is greater than 0 is this, because this is y equals 0, and it's going here. So that created 1, 2, 3, 4 corner points. And this, now if we talk about our shading, and I don't have another color, but I'm just going to try to show you with my arms and hands and feel like a little bit like an air traffic control, well, not an air traffic controller, but the person out there with the cones directing the airplanes, right? So x plus 5y less than equal to 35 was our green line. And if we shade below, you would start at the line and shade below. Our pink line is 6x plus 2y less than equals 42. If we shade below, that means we would shade in this direction. X is greater than or equal to 0 means we would shade to the right, and y is greater than or equal to 0 means we would shade above. So what that creates is this feasible region. Because what this region represents the overlapping. Remember, in my definition, I specifically mentioned the word overlap. So it's where all 4 of these inequalities, where their shading intersects or where it overlaps each other. So this little box with the dashed lines in it, this is the feasible region. And that feasible region, these 4 corners, the ordered pairs of those intersection points are what we're going to use in our objective function to maximize it. So the next step is to find the ordered pairs of your corners. And thankfully, 3 of the 4 we already know from the work we've done setting up the lines and drawing them. So I'm going to start with this one. I'm going to call this one number 1, 2, 3, and 4. So point number 1 is 0, 0, because that is our origin. Number 2 was our y-intercept for the green line, and the y-intercept for, I'm sorry, that was for, that is 0, 7 actually. So that was 0, 7 for number 2. The third line, I'm not really sure what this one is, or the third corner point. I'm not sure what the ordered pair of this would be. So this is the one that we're going to have to find by solving this system. But we can see that number 4 is our x-intercept from our first line, which was 35, 0. So let's now work on finding point number 3. So some of the corner points we'll know from work that you've already done. And if you can't determine it clearly, like these are 0, 7, 35, 0, etc. Oh, I'm so sorry. I've made a typo here. I looked over here. Number 4 is not 35, 0. I'm sure you were going to send me an email and correct me. Number 4 is 7, 0. Okay, so 1, 2, 3, 4, we've got 0, 0, 0, 7, 7, 0, and then we're going to find number 3. Okay, back to point 3. So to find this missing ordered pair, you will use the inequalities of the 2 lines that created that intersection. So this was equation number 1, this was equation number 2. So we are going to solve the system by, let me write them down, x plus 5y. Okay, so as I told you earlier, there are 2 methods to solving, the elimination method or the substitution method. And for this example, I'm going to do the elimination method, which means that we would multiply one of these equations by whatever factor is necessary to get opposite terms so that one of the variables here, the x or the y, would be eliminated when we add the 2 inequalities together. So, and also this is a place where some students like to say, well, you know what, since I'm solving this system, it makes more sense for me to put equal signs temporarily to solve, and then we can put the inequalities back at the end. So I'm going to eliminate the x variable. This has 1x, this has 6. So to eliminate, I need the coefficients to be the opposite of each other. So I'm going to multiply this by -6, okay? And I'm going to just use my finger to change the terms. If I multiply -6 by x, that gives me -6. If I multiply -6 times 5 here, that gives me -30. And if I multiply -6 times 35, I get -210. And now I can add these 2 equations together. The 6x and -6x and 6x are gone. -30y plus 2y is -28y. And -210 plus 42 is -168. Dividing both sides by -28. Y equals +6. So now that I have the y value, I can take the y value and plug that back into one of the other equations and find the x. So let's use the first one. I'll change colors so you can see. So we are going to do x plus 5 times 6 equals 35. So that's x plus 30 equals 35. And if I subtract 30 from both sides, x is 5. So that means the point where these two lines intersect has an ordered pair of 5, 6. So now we have everything we need to finally answer the question of linear programming. How do I maximize this objective function? You find the feasible region by graphing the lines. After you find the feasible region, you identify your intersection points that create that region. Now, we were able to look at the graph and get 3 of the 4. The 4th one we had to find by solving the system of equations, and then I used the method of elimination to do that. Now that we have these 4 ordered pairs, we are going to plug every x and every y into this function to see which one is going to give us the greatest value. So I hope you're hanging in there with me. We're almost done. Okay, so these are our corner points. And then we are going to use that function of z equals 5x plus 2y. So if I plug in 5 times 0, I don't know if I'm going to have enough space, but we'll keep going. 2 times 0, we can clearly see that z would be 0 in this case. If we plug in the second order pair, which would be z equals 5 times 0 plus 2 times 7, z is going to equal 7 times 2, which is 14. So far we have z equals 0, z equals 14. In our third corner point, we're going to have z equals 5 times 7 plus 2 times 6. So z equals, this is 35, this is 12, and 35 plus 12 is 47. And lastly, we have z equals 5 times 7 plus 2 times 0. So we have z equals 35. I just want to check. I think I used the wrong number here. This should be 5. So I'm making sure you guys are paying attention. That was a test. I was looking at my number thinking, this is not right. Okay, so 5 should be here, and 6. 5 and 5 is 25. 25 plus 12 is 37. So we have maximized our function, or we have input our corner points into our objective function, and because you were asked to maximize the function, that occurred when x was 5 and 6 was, when x is 5 and when y is 6, because we got the greatest value of 37. So 5, 6 maximizes the function to z equals 37. You could also be asked to minimize the function, and if you were asked to minimize the function, our minimum value would be z equals 0 at the origin. Please let me know if you have any questions after watching this video or working through this example. Thank you for watching.